Hi, in this video you're going to learn how to generate several types of weird textures procedurally. Basically, all the masks that will enable us to go from a simple, almost clean material like this one to a worn and dirty material like this other one. We will go through a few techniques that should enable you to create physically plausible content thanks to Blender simulation tools. This should not only provide you with more realistic textures than the ones painted manually, but it will also allow you to save time by cutting out this manual work, given that you are able to run the simulations on a separate computer or at night. The methods we will go through were designed so that no manual painting is necessary. Many of these steps required a lot of tweaking and messing around. You should definitely try playing with the parameters to get something right for you. In the first video, we will cover how to use particles and dynamic painting to generate a rain dirt mask. In future videos, I would like to explain several other methods. First, how to generate a rust mask using a similar but more advanced method than for the rain dirt. Then, how to bake worn edges into a texture, but using a different method than the classical pointiness input in the node editor. We will use dynamic painting again for this one. We will also see how to generate scratches procedurally. We will then cheat a little and use the ray tracer's lighting physics to generate an abrasion mask from a specific direction. Here, the abrasion comes from the front because of the ship's swift forward movement. I also use ambient occlusion here to figure out where dust should accumulate, but I believe this method is already well covered in other tutorials. Alright, let's get started. In this section, we're going to use the particle system as well as dynamic painting to bake a rain weathering mask in a texture. The main benefit from using a physical simulation to generate this mask, additionally to not having to paint it yourself, is that it's going to generate many interesting geometry related details. For example, here, rain accumulated in crevices where two metal plates join. This middle section got protected from most of the rain because it's a little sunk in. However, it still received some splashes from the surface at the bottom. On the front section, rain streams gathered because of the rounded shape of this cockpit geometry. And of course, the parts facing upward got much more exposed than the vertical parts. We will then use this mask to apply a rain dirt material on our model. You can start by this step because it's one of the most straightforward use of particles in our workflow, and also because it doesn't rely on any previous steps. But before we delve into how to generate this rain mask, let's have a quick overview of our model and its material. I chose to have only one shader for the whole model in order to keep everything in one place. Material type from one surface to another is determined by a texture mask, which is about the only thing I painted manually. Materials are grouped in frames in order to keep things tidy. This is going to be really helpful when the shader gets bigger. Here you can see the glass material for the cockpit, metal, another type of metal, and the paint material. Here you can see the combination of these materials using the masks. This is the base look of our model before generating any details. Regarding the model itself, I chose to have it represented by a single object. This is to be able to bake a mask in one go and save time. If your model is more detailed and has several different parts, you can always repeat the process for each part. Needless to say that your model should be watertight, since we're going to simulate water flowing on it. Last but not least, the unwrapping of your model should be handled carefully. First, you should probably have a set of UVs dedicated to baking. Then, make sure that your UVs don't have too many disjoint surfaces, because the dynamic paint algorithm is going to crash otherwise. You wouldn't want your rain simulation to overflow, would you? Also, each texel should have only one corresponding 3D space position. That means that you have to make sure that you don't have any surfaces overlapping in your UVs. Now that you have a clear view of what your model should look like, let's proceed to generate this rain mask. The first thing to do before baking is the rain particles simulation itself. I placed several particles emitter planes to make sure that every part of the model would be exposed the way they would be exposed to rain. At the bottom, this shape is here to kill particles that we are sure will not contribute anymore. This helps reducing simulation time. You want to make sure that the rain flows nicely on the surface, so be careful with the damping and friction of your surface. You can then launch the simulation. I recommend always baking it somewhere to verify the first time that your particles don't do anything silly. In the end, it should look something like this. You can already see the general flow and the crevices where particles get stuck. We are now ready to set the dynamic paint parameters. In the physics panel of your particle emitter, turn on dynamic paint and set it to brush. You want to remove absolute alpha because you want the paint effect to accumulate. Set a white color and define alpha to a low value. This is the maximum value a particle will add in the texture each time it contributes to it. So we want to be able to see a lot of iterations before it reaches the maximum value of 1. This is if, like in this example, we're not using a floating point texture. Set the paint source to a particle system. Set your particle system. Now we can set the paint radius. The solid radius is going to have the alpha amount printed in. I like to keep it as small as possible. The smooth radius is going to define the fall-off of the particle printing beyond the solid radius. The bigger it is, the more diluted your rain dirt will look. Then we can set the canvas we're going to draw on. Select your model, go to the physics panel, turn on dynamic paint, and set it to canvas. We're going to draw in a texture, so the format should be image sequence. Change the resolution to the one desired. When making tests, keeping this low will greatly reduce baking time. Then define when your baking should start and stop accumulating particles contribution. I start accumulating at frame 10 here because it corresponds to the moment where the first particles hit the surface. Add some sub-steps. This will draw particle contribution between frames. It helps creating a line effect rather than having a series of dots drawn on the canvas. Surface type should be set to paint. Remove the dry option. If enabled, it would cause the values in the texture to decrease over time, but the rain dirt is not going to magically clean itself after a while. Select your baking UVs. Define a path and a meaningful name to keep things tidy. Set the initial color to a black color. You can then finally hit the bake image sequence. It can take a really long time depending on your different parameters. It was a matter of hours on my 3.2 GHz quad-core i5 CPU. I'm not sure, but I don't think it's using any GPU acceleration. Blender will generate a batch of images displaying the accumulated effects of our particles over time. You can then use any of these images as a mask for your dirt effects. In my case, I chose the 110th iteration. And this is all you need to do for the mask generation. When you want to use it, don't forget to use the data in linear space. So, non-colored data as the color space, and you should be good.